Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Now, success is not only the project success, the success is all about the civil engineer, quality control engineer. We are discussing the strategies also. So, what is today's topics? Today's topics is not that much of prominent, but it is very much important in concrete, but sometimes it is overlooked. So what's that? That is a alkali aggregate reaction. We are not thinking so deeply what is that, but it has the huge impact or immense impact on the concrete strength and the durability. So today's topic is all about the alkali aggregate reaction. So stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. Things, what is alkali aggregate reaction? Now, before 1940s or 1950s times, we are always thinking that this aggregate what are using, that is inert in reaction. It is not giving any reaction into the concrete. So what we know that the concrete is only reacting with the cement and the water. But later on, we found there are some reactive material present in the aggregate itself who are highly reacting with the alkali present in the cement. So after that, these come into the picture, and it is now a varied and wide topics on the concrete technology, that's alkali aggregate reaction. Now we are now getting that the aggregates not in react non reactive, not it is reactive if there are some certain particles of reactive particles present. So alkali aggregate reaction is a chemical reaction that occurs in concrete between the alkalis, that is the sodium oxide and the potassium oxide present in the cement. All we know that inside the cement we have the sodium and the potassium and as a form of sodium oxide and the potassium oxide. These sodium oxide and the potassium oxide, what they're reacting with the silica present in the aggregate. Now, this is called the alkali silica or the alkali aggregate reaction. So before we are thinking that only this aggregate has no chemical reaction with the cement, but now it start reacting with this. Now it is not reacting immediately. If there is no water, they will not react, or they will not forming the what is, they will come later. But in the presence of water and the temperature, in the same temperature, there is a different range of temperature, these start reacting and called the alkali aggregate reaction, or in terms it is AAR. So there are two types of aggregate reaction. One is alkali silica reaction, we call the ASR, that is most common, involves reaction silica in aggregate. So reactive silica present in the aggregate, it start reacting with the alkalis in the cement, that is the sodium oxide and the potassium oxide, that we called the alkali silica reaction. Another is alkali carbonate reaction, that is ACR. This less common, involves certain carbonate rocks. So that is less common, but still this type of reaction also is happening, that we called alkali carbonate reaction. Another is alkali silica reaction. Both are terms as an alkali aggregate reaction. Now, what if alkali aggregate reaction will happen? What will happen? Why you are discussing these things? So I will come later one by one because it is very much important for the concrete strength. Two types of alkali aggregate reaction, and what is alkali aggregate reaction, that you already known. Now, what is the factors promoting the alkali aggregate reaction? Now, why this reaction is happening? The first thing is reactive type of aggregate. Now, which one is reactive type of aggregate, that we want to know, because all aggregate is not reactive, all aggregate has not that reactive silica present, but that we need to know which type of aggregate, or what is the aggregate percentage, or what is the reactive type of aggregate. If the aggregate is not reactive type, this AAR will not happen. And then availability of moisture, it is very much important. Without moisture, reaction will not happen. See, that is why we need to protect our concrete from ingress of the moisture inside the concrete. If not only this alkali aggregate reaction, without moisture or without the water, nothing can happen. the carbonation will not happen, chlorination not will happen, sulfate reaction will not happen, anything. So the moisture plays a vital role in concrete. So availability of moisture also important to happen the alkali aggregate reaction. Then high alkali content in cement. So it is all in this Na2O and the sodium oxide. We present potassium oxide and sodium oxide present in the form of alkali in the cement, and it is reacting with the reactive part of silica or in present in the aggregate and called the alkali aggregate reaction. So total alkali content as expressed in Na2O equivalent is less than 0.6%. So if the total alkali in the cement is less than 0.6%, we can say that our concrete is safe from the alkali aggregate reaction. So what you are making concrete, or what is our criteria, or we are targeting to make it within the zero point 0.4. So if it is zero point 0.4, it's less than 0.6. So it's a very rare it will happen the alkali aggregate reaction. Then optimum temperature conditions, it is around 10 to 80 degrees centigrade. If this in between this, the alkali aggregate reaction will happen. So what do you know this, what is alkali aggregate reaction and types of alkali aggregate reaction and factors promoting the aggregate reaction. Now the last part will come, how to prevent the alkali aggregate reaction. So it's a simple. What is the reason that we have to close that one? So this reaction will not happen. So next part is that I am discuss here, that reactive type of aggregate. How you know that whether this silica or this aggregate is reactive type or not? It's very difficult. There are different measure to test that one. That is, one is petrographic examination, Mortarboard expansion test, and the potential reactivity by chemical method. These three are using to measure how much reactive silica present in the aggregate, which can start reacting with the alkali present in the cement. So you need to know how to know that what is the reactive type percentage of aggregate silica is present inside the aggregate by these three method. So whenever we are selecting aggregate, ask the RMC supplier that what is the reactive percentage of silica in the aggregate, so that I can assume what is the AAR reaction will happen. So this is the how to determine the aggregate. Now, next part is what is the mechanism, how this AAR reaction is happening. That we need to know. That we already, or that I have already discussed, that this alkali present in the cement and the reactive part of the aggregate, that is silica, with the help of moisture and the favorable condition, the reaction is happen, that is called the alkali aggregate reaction. But what is the process or the fundamental? See here, you can see first is formation of alkaline solution due to water and alkali from the cement. So in the cement itself, we discuss Na2, Ka2 is there, sodium oxide and the potassium oxide, that is alkali is there, and water we are adding into the water, or if the moisture is coming inside, so it is present what making this alkaline solution, because Na2O K2 is there, it's become alkaline. Now if this alkaline solution react with reactive silica and making a alkali silica gel. So first things, the with the presence of water, the alkaline solution will prepare. Why? Because the alkaline from the cement is Na2O K2 is there, sodium oxide and the potassium oxide, they will form an alkaline solution. And this alkaline solution will react with the reactive silica and form the alkali silica gel. This alkali silica gel in swelling type, that means it will increase. So reaction process more rapidly start happening, and the silica gel grows in size. Now, if the silica gel is grows, what will happen? It is exert the osmotic pressure, resulting cracks on the concrete in pattern on the surface itself, because mainly this reaction is happening on the surface of the concrete. So due to this exert osmotic pressure in the pattern, the cracking is generating, and if the cracking is generating, resulting in strength, loss in strength and the elasticity. So if it is loss in the strength, the concrete, whatever the intended for the design, that will not take that much of load. And the elasticity problem, that is also due to certain load, or when the load is increases, it will not withstand, or the structural stability will be in a problem. So this is a problem for the strength and the elasticity. Now, why the durability problem? Because when it is crack, it's in the pattern in with the cracks, again the moisture, carbon dioxide, sulfate, chloride, magnesium, all the reactive ions will penetrate inside the concrete. Carbon will do the carbonation, chloride will start reacting with the uh, reinforcement, and corrosion will happen. Sulfate will do the ettringite, and it will again deteriorate the concrete. So durability also will be the problem. Maybe it's the small things we are thinking, that the reactive silica or the alkali present, but it has the huge impact because it's giving the chain reaction. First it itself deteriorating the concrete, then again it is making the path to enter the other ions, so the durability has become the problem. So these are the all air reaction phases. First, the alkaline solution is forming, and then alkaline solution react with the reactive silica and making the alkaline silica gel. This alkali silica gel is soiling type, so it is increase in the volume. Then this reaction process more rapidly, then silica gel grows in size, and then it is exert osmotic pressure, resulting cracking in the concrete and pattern on the surface itself, and a resulting loss in strength and electricity, and cause of durability concern. So although it is very less, but it has huge impact or the negative impact on the concrete. That is why we have to deal this alkali aggregate reaction very carefully. Now, the next part, when you know that this can cause my concrete problem, I need to prevent that one. How to control AAR, or the alkali silica reaction? So first things, why it is happening? Because the alkali present into the cement. So we have to go for the low alkali cement. So we know that 0.6% is the maximum alkali percentage can be allowed. So we have to go for the lower alkali cement, so that there will be no alkaline solution, or it will not start reacting with the silica. Then non-reactive aggregates, if there is the reactive part of is not present in the aggregate, it will not react with the alkalis in the cement, so the air will not happen. So low alkali cement and the reactive aggregates, non-reactive aggregates, and the use of supplementary cementitious material. Why? Because with the help of supplementary cementitious material, we are reducing the alkali percentage. So again, it will not reaction will happen with the aggregate. Then limiting the cement content, that is all we are doing now. The cement content is one, and we are replacing with the GGBS or the fly ash, as called as the supplementary cementitious material. Again, it is helping to lower the alkali content of the cement. And then waterproofing of the structure. Why? See, we are know that if alkali is also there, reactive silica is also there, but if the moisture is not there, the reaction will not happen. So if we can protect our concrete from the moisture ingress, our alkali silica reaction will not happen. So not only alkali silica aggregate reaction, the other things also, the carbonation, chlorination, sulfate attack will not happen. So in this way also we can protect our concrete from the alkali aggregate reaction. So what we discussed today, what is alkali aggregate reaction, types of alkali aggregate reaction, factors promoting the alkali aggregate reaction, how to determine reactivity of the aggregates, what is the alkali reaction process, and how to control alkali aggregate reaction. So these are all about this, and I hope in your next project you will always, whenever you are selecting the aggregate, you will think, or whenever you are selecting your mixed design, you must consider this alkali aggregate reaction in the criteria itself. And if you like this one, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.